guys, in this video we're going to talk about mean absolute deviation, and we're going to call it MAD, mean absolute deviation. So let's talk about what those words mean. Mean, the first word is mean. What is the mean? That's the average of a set of data. Absolute, think about absolute value. Deviation. Deviation means how much spread out the data is. So I know you talked about with box plots how spread out 50% of the data was. So now we're going to take the MAD and figure out how spread out the data is. Actually, box plots is what you're going to be, I don't like that. So in order to do that, it's on average how far the data pieces are from the mean of the set of data. So step one, find the mean. Add them up and divide by how many there are. Find the distance from each piece of data to the mean. You'll use its absolute value. I tend to just switch it around, but you can. And then step three is the mean of those numbers. So let's do one together. Grab a sheet of paper to do the work because you'll have to input it. So let's find the mean. I always like doing my numbers in order from least to greatest just to help my brain. So 75, 85, 90, 95, 95, 100. So I already added those up, but grab your calculator and add them up. And you get 540. And there are 1, 2, 3, 4, 5, 6 numbers. So we're going to divide it by 6. So our mean of this data is 90. So then we have to find out how far away each number is from 90. So 90 minus 85 gives us, sorry, I'm going to go from 75 starting in my rewritten order is 15. 90 minus 85 is 5. 90 minus 90 is 0. You still have to include the 0 in the data set. And then 90 minus 95 is negative 5, but you do the absolute value of 5. Same thing, 90 minus 95 is negative 5, absolute value of 5. And then 90 minus 100 is negative 10, absolute value of 10. So then we take the 15, 5, 0, and 5, and 10, add those up, and we get 40. We divide by how many there are, and it is 6.7. So those numbers were pretty far apart. They were about 6 above and about 6 below. Because if you look at like the 75, that kind of brought it down, but you also had the 100, which was 10 above. So it's about 6 below and about 6 above. So that is the mean absolute deviation for this set of data. You find the mean, the average, you add them up and divide by how many there are. You find how far each number is from 90, and then find the mean of those data, that data. And then that is your mean absolute deviation. Go ahead and make sure you insert your work onto the next slide. So if the MAD for a set of grades is 3, the MAD is 3, which statement might be true if you're able to say about the grades if the mean was 80 out of 100. So think about the MAD is 3, the mean is 80. So the average is 80, so the MAD is 3. So let's see which one is true. Student scores between 80 and 83. Well, that means it's 3 above. Okay. So the student scores were 83. Well, that's not true because we know that they can't all be that if the mean was 80. We don't know if necessarily they got all B's, and student scores were between 77 and 83. So remember how I said on the last one, it's going to be kind of 6 above and 6 below, right? So again, I think it's going to be D because it's 3 below and 3 above the average of 80. We don't think everyone got B's because they could have been below the 80. And then this one didn't bring the numbers below. So remember, the mean is your middle, your average. Your MAD is your numbers that direction, positive and negative. So for your explanation, you could say the answer is D because the average of 80 and then you had 3 points above, 3 points below to figure out the spread of the data between 77 and 83. So go ahead and explain that one. And then there's a few more practice problems. I think there's 2 more practice problems finding the MAD. Remember, you have to find the mean, the distance from the mean to each number, and then the mean of those numbers. And go ahead and insert your work for the next 2. And I hope you enjoyed this video on MAD.